All right. As promised, we are about to start Chapter 9, and in Chapter 9 you are actually going to remember a lot of the prior concepts because it's just a review of SOHCAHTOA in the first part and a review of the idea of angle of elevation and angle of depression. So the one thing we need to get straight in Chapter 9 is just the way we label triangles. So if you're told an angle B and a side B, those should always be opposite each other. If you're told an angle A and a side A, those are always opposite each other. All right, important things to remember is the Pythagorean theorem, a squared plus b squared equals c squared, and that in a right triangle, we have, if this is a 90-degree angle, then the other two angles together have to add up to 90 because remember, all together they have to add up to 180 degrees. So if I wanted to go ahead and solve this right triangle here, I would first be able to tell right off the bat that angle B has to be 50 degrees. All right. And then if we just go ahead and look for A and C, I know this side here, and that's the adjacent side. And A is the opposite side, and this is if I want to use the 40 degrees. Now, remember, it changes how you label your triangle on the angle. So I'm focusing in on the 40. If you focus on the 50, which is my angle B, then the 2 would have actually been the opposite side and A would have been the adjacent side. But regardless, C is the hypotenuse. So from here, I could say that tangent of 40 equals A over 2. Now, when I go to solve this, we are now in Chapter 9 using our calculators for everything. So first thing you need to do is make sure your mode goes to degree mode, which does present the issue on the final exam. You are going to have to jump back and forth. Graphing, Chapter 7 stuff, Chapter 8 stuff was all in radians. So graphing and inverse trig was in radians. But now we're going to stick to degree mode because just looking at our triangles. So tangent of 40 is going to be an 8.39, and move that over. And so what I like to do in these, and you guys are going to be much faster at these, but I'm just kind of showing all the steps right now. This is an 0.839 equals A over 2. This just makes a ratio. So I'm going to multiply that number, tan 40 by a 2, and that tells me what this side has to be. So it's a 1.678. All right, and that's my final answer. All right, now for C. So for side C, I can either use the Pythagorean theorem or just use trig again. So if I want to use trig, since again I knew that adjacent side and I need to know the hypotenuse, you probably would say cosine of 40 equals 2 over C. And so I'm going to do the same thing. Remember, cosine of 40 is just some ugly number. So we actually have C times that ugly decimal of cosine 40 equals 2 when I cross multiply. And so C has to be a 2 divided by cosine 40. Now, if you want to get the ugly decimal right away, go for it. I'm just writing this out. And now when I go to type it in my calculator, I'm going to get a 2 divided by cosine 40, and we get a 2.61. So C is a 2.61. All right. Now, if we go ahead and look at the next example, all right, what we're doing here is we actually have to be able to find the angles in this one. So in triangle ABC, oopsies, oops. If I label this side as my A, or that angle as my A, then this side has to be the 3. If I label this angle as a B, then this side has to be a 2. All right, so to find C, that would imply the hypotenuse. Let's just go ahead and say 2 squared plus 3 squared equals C squared. So that's going to be a 9 plus a 4. So this is square root of 13. All right. Now, to find angle A, I would say, and I could use any of my side lengths now. I'm going to stick with the two that I was given. So I would just say tangent of A equals a 3/2. So then A is going to be whatever inverse tan of 3/2 is. Now remember, we're in degree mode now, so we don't have to worry about all the rules and all the stuff we talked about in Chapter 8. We get to just type this into our calculator and get the degree measure for inverse tangent of a 3/2. So angle A is a 56.3, and remember, we know A and B add up to 90 degrees, so I'm just going to go ahead and subtract the 90 away. And that tells me my two angles. All right, obviously angle B is a 33, not a negative 33. I just think it's easier to type it all in one quick step. So angle A was 56.3, angle B is a 33.7 degrees. All right. So let's look at this one. If I had to find x in this problem, this is a Pythagorean theorem problem again. So a 3x squared plus a 4x squared equals a 3 squared. So I could say a 9x squared plus a 16x squared equals 9. So I actually end up with a 25x squared equals a 9. So if I go ahead and divide, x squared would be a 9/25. So x is a plus or minus. So all right, so plus or minus 3/5. And then here, we obviously, since it's a 4x and it's the length of a side, we're not going to use the negative value. So we would say x is a 3/5. Now, all right, so an angle of elevation, and this is the last big thing in 9.1, is you're going to hear two different words in 9.1, an angle of depression or an angle of elevation. So if we were talking about an airplane and you asked about the angle of depression, all right, versus if you were thinking of someone looking up at the airplane, then what we would say here, and the most important thing I need you guys to understand, is regardless of which angle I say, elevation or depression, it's actually always talking about the same angle. So an angle of depression is always formed with the horizontal looking down. An angle of elevation is always formed with the horizontal looking up. So try to remember from geometry, these are actually alternate interior angles. So they're always going to be equal to each other. All right. Now in this problem, they actually labeled it for you, but the angle of elevation looking up, this 10 is the radius of the circle. So we know that's 10 also. So in this one, I would say tangent of x equals a 10/35. You don't know the hypotenuse, so you can't use sine or cosine, but we do know the adjacent and the opposite and the adjacent, so we use tangent. So I would go ahead and use my calculator and do our inverse tan of 10/35. And this angle would have to be a 15.9, or we could even go and call it a 16. All right, a 16-degree angle. And so then the Willis Tower in Chicago is the tallest building in the U.S. and is topped by an antenna. Surveyor on the ground makes the following measurement. The angle of elevation to the top of the building is 34. All right, so we have a person. And that person is looking up to the top of a building. All right, so I'm going to All right, and they say to the top of the building is 34. All right, the distance from her position to the top of the building is 2,593. and the distance from her position to the top of the antenna. So this is the key thing. On top of the building, there's an antenna. So what that tells us we have to do is have something up here. This is the antenna. And then there's another line that we're going to get for her line of sight to the top of the antenna. All right, so now let's look at these two measurements we have. We have one measurement, which is the 2,593. And we have a second measurement that is the 2,743. All right, how far away from the base of the building is she located? All right, and then the second question is how tall is the building? And then the third question wants how big this whole angle is. So not just the 34, but with this little chunk for the antenna angle included in it. So let's go ahead and, oops, I keep trying to move that. There we go. All right, so for the first part, what I would recommend to do, and the part I like to find quicker, is just if we look for this x value, that is a cosine problem. So to answer part A, I could say cosine of 34 is equal to an x over 2,593. So if I go ahead and put that in my calculator, I'm going to get cosine 34, and I'm going to multiply it by the 2,593. All right, so that's my first answer. And then it asks, how tall is the building? So now that I know this, and I know the 2,593, that could actually just be Pythagorean theorem, or again, you could use sine. So for part B, I'm just going to use sine, but again, feel free to use Pythagorean theorem. I could say sine 34 equals the building length over, all right. So I'm just going to go back to my calculator, and I'm going to drop this back down, but I'm going to use a sign in the front. All right, and so now I know A and B.